When building out this agent system platform, one of the key components that I use on my system is a queue so that users can kick off various jobs concurrently, and those will get picked up and then execute an agent runner to run Claude Code or Codex over whatever the request might be. So for example, if I go to a GitHub issue here, if I say agent system : review, and I give it a message or a body, the agent's going to pick that up, it's going to run some work, and then it's going to go and update this issue. For example, I told it to just ask it a question, is this a good issue to work on? And it came back with its analysis if I should even work on this issue or not. But later down here, I can say, hey, go ahead and implement this in a pull request, and then give it some time and it'll actually start doing this. In fact, let me just go ahead and do that. Let me copy this and I'll just say update, implement this in a PR. Now, if I go back to agent system, what's happening is I have these events that are hooked up. For example, the worker that I just fired, I can give it a custom prefix. That's going to run that event that we just talked about. Here's the job that's running. And then it's going to kick off Cursor. I believe I'm using Grok 4.5 to do a lot of the implementation because I do think it's a pretty good model. But at some point, this will finish running, and then I'll have a pull request that I can actually merge in that's related to this work. So under the hood, how exactly does this work? Because if you have a multi-tenant system, there could be a lot of users pushing in events into a queue, and you really don't want one noisy neighbor to suck up all the capacity of your system. So let's kind of break this down. I'm going to start really simple. We have a user here. We have a queue. So I'll just say SQ. And then we have some type of worker. In this case, I'll just say a Lambda function, and this is our worker. Technically, I'm going to call it a launcher. I'll kind of give you some insight into how the system I'm building out actually works. So we'll say this is a launcher over here. And what happens is a user is going to interact with the dashboard. That's going to hit a control plane. The control plane is going to enqueue a message into this queue. And then the launcher eventually picks it up. Now, like I mentioned, with this approach, a user can keep on enqueuing messages. And for example, if this is a premium user, they might enqueue 100 agent messages at the same time, which is problematic because now if another user tries to actually use the system and they want to create a message, I'll just go ahead and tag them with a different color like purple, and they make their own message over here purple. That gets sent to the back of the queue. So this 100 messages from user A, it's going to take up the entire capacity of the system. So I needed to figure out a way to have a nice fair distribution of these messages. And this is what leads us to the next topic. Hopefully you understand what a queue is. It's a way to put messages and you can have workers pull from them. But we're going to be using something called a FIFO queue. So a first in, first out queue, which to kind of give you some information, this also allows you to give a message group ID, which kind of segments the messages by different users. So for example, I could have this message, have a message group ID of A. This could be for like user A. This one, again, could be user A. And then this one over here could be user B. Now, the reason we end up using a FIFO queue is because you can have the message group IDs basically shard out the work. And so the launcher, instead of it just pulling all of these messages from in order, technically behind the scenes, there's almost like separate queues for all this. So if I go ahead and just put like a, technically a queue over here, and then I'll put a queue over here. Again, it's just one queue in AWS. You only configure one queue, but internally, they have a way to distribute the messages so that when the launcher runs, it can only pull from one message at a time from that particular message group ID. So again, this makes our system a little bit more fair because even if this user A is a premium user, they're paying more money, they kick off a ton of messages, that doesn't prevent all these other users who also want work done to get picked up. So the launcher will still kind of go through and pick from the queue that doesn't have an active message. So for example, if this user doesn't have any message getting processed right now in the launcher, then it's going to be the next one to kind of pull from. And we could have a bunch of these. Some of them will be in progress. For example, group B is in progress, so it's not going to get another message pulled from it, even if they have like 10 or 20 different messages queued up. So this is great. We have the launcher, and then when the launcher picks up the message, it does some checks to say, hey, does this user even have capacity? Are they at their run limit for the month? And if everything is good, we then go ahead and just kick off the micro VM, which is an AWS service that you can actually run, a Firecracker instance, and then I run Claude Code inside of that. And I have a capacity limit on that as well. So there's like a Dynamo database over here. I'll just say like database. The launcher reads from the database. It also tracks how many micro VMs are kind of running so that we don't try to spin up too many of these at the same time. Now, I might be all over the place because there's a lot of stuff that kind of I can talk about with this system, right? So when it comes to a FIFO queue, there's actually something called maximum concurrency, which you can set up to like, I believe like 1,000 or something, or you can set it to 1. And this is going to limit how many active messages the launchers can actually pick up. So if you have this set to 1, this means that you can only run one worker launcher at a time until this is done, and then we can go ahead and just pick up the next one. Now you might ask, like, why do we do this? This doesn't really make sense, because there are request limits for how many of these micro VMs you can spin up, right? When you create a new AWS account, your requests per second, I do believe it's called a transaction per second for micro VMs, is set to 1. So you can only spin up one of these things a second, which means that if you try to set maximum capacity to 1,000, it doesn't matter, because this launcher is going to keep on trying to spin up a bunch of micro VMs. It's going to keep failing because AWS is going to have rate limits. And now you're basically just wasting a bunch of compute trying to keep on spinning up micro VMs when you don't have capacity. So there's kind of a balancing act of, like, what should this be set to? Really, it's based on your account limits of how many of these things you can spin up a second. Also, there's there's limits on, like, how many gigabytes. So I'll say, like, memory. I do believe when you create an account, it's set to like 8 gigabytes. And these micro VMs can take like 2 to 6 gigabytes depending on your settings. So technically, I can only like run 2 or 3 of these at a time until AWS comes back and actually like increases my limits. Which, if they don't, then this whole system is basically pointless to build out. But if they do increase the limits, for example, I asked for an increase to 5, and then I asked for an increase to, I think, like 1,024 gigabytes, so I can actually run a bunch of these concurrently. I can then probably set my maximum concurrency to like 4 or 5, right? So that I don't try to spin up too many of these things at once. Now, additionally, let's talk about the fair distribution, right? Let's say user A is a premium user. They're paying like $100 a month for this platform, and they have the ability to spin up like 100 micro VMs at the same time. We probably want to allow this user to be able to run more messages. They're paying more, they're a premium user. We should probably allow a little bit more of the allocation instead of user B, who might be like a $20 a month user. They're on the basic plan. So there's another thing I want to talk about, is something called sharding. You can actually attach a shard ID. So I could say this will be shard 1. And for every message, you basically just attach on some type of random shard. Okay. Now, like I mentioned, when the group ID is different, you basically have behind the scenes almost like a different queue. So there's going to be like a different queue for shard 1. I'll just say like hash symbol 1 there. And then this one will be hash symbol 2. So when this user tries to actually run something, for example, there's a control plane over here, control plane, and they're going to be interacting with the control plane. The control plane is going to figure out what user they're on, what plan they're on. And if they have a premium plan, we can actually just give them more shards so that the launcher can kind of step through and give them more concurrent spin up, right? More capacity, so they could potentially be kind of in front of the queue. They have premium access to spin up all of these micro VMs versus someone like this has a lesser shards. They might have like a shard of just like a max of 1 or something. So every single message is just going to be a shard of 1. They have no additional fan out, no additional concurrency. So it's just a matter of a chance that their message gets picked up, versus this has like a more of a priority, right? It's kind of like a priority queue under the hood. And that's how you kind of get it set up in AWS. So you can have multiple of these things running at once, and then potentially you'll have your maximum capacity. This message might not get picked up compared to these two. All right, so I think that's as much as I want to dive into in terms of queuing, FIFO queues, how you can actually use like unique keys inside your group ID to do some type of sharding simulation so that the launcher can pick up fairly and kind of give some users more priority. It's just a heuristic. There might be better ways to do this, but this is a way that I've done it inside of Agent System. And if you look here, the job that I kicked off, I think is actually done now. I got a pull request that's created. I can go through here, I can check it, and it did a bunch of work to basically do that. Now, granted, I probably kick off a couple more agents just to do a review on this, and then I can kick off an agent to fix merge conflicts on this. But I'm starting to transition to all of my development actually being directly in GitHub, because I found that you can have GitHub be your knowledge base. All of your issues and your pull requests has information about how your system's evolving. You can link these issues to previous pull request issue numbers, to previous issue numbers. So when you ask these agents to basically do work, it can kind of fan out and grab more context to more successfully do that. Granted, I am still using mission control a lot for a lot of my projects, which is in the link below if you want to actually play around with this. It's free to use. This is how I kind of manage all my different side projects. I'll kind of switch between them. I'll kick off jobs. I'll come back. But Swarm's the one I've been kind of focusing on the most. And hopefully you guys enjoyed that little overview of how you can use AWS and SQS with FIFO queues in this sharding type of approach with message group ID to get this all kind of set up. All right, have a good day and happy coding.